Hey everyone, welcome to another lecture of this JWT Authentication System playlist. So, in here, I am going to explain what MVC is. So, in the previous lecture, which was about the course announcement video, so over there, I discussed that in this project, we are going to use the MVC architecture. And that is why I am going to, dive deeper into this MVC architecture so that it's clear for you, right? So, pretty simple. MVC stands for models, views, controllers. Now, what is it? So, it's an architecture design following which we can build backends in a way such that number one, it follows this SRP principle. Now, what is the SRP principle? So, SRP is a single responsibility principle which states that one function, so let's say that you have a function which is this. So this function, it should just do one single task. So it should not do multiple tasks. Its primary responsibility is to just do one single task. So that is what SRP principle states, and it is one of the solid principles which is followed a lot in software development. So one function should do just one single action properly and effectively. So that is what SRP principle is. And number two, why we follow this MVC is because it ensures scalability. Now, what is scalability? So scalability is that, let's say that you have built a backend project. Now, how can you scale it? So scaling can definitely include facts that you are adding some more features. So you are adding some more features, you are adding more business logic, or you are adding more endpoints. So whenever you do, or whenever you add features, your project should be scalable. So you should not have any problem when you are trying to scale it. So in order to do that, you have to build the project in a way that it is very much easy to handle. So it ensures scalability, it ensures extendability. What is extendability? Extendability is how easy. So let me write it over here. So extendability is nothing but how easily you can add more features to your backend project, right? So it is how easily you can add more and more features to your backend project. All right, so that is what extendability is, like how extendable, like how easy it is to extend your backend project. And third, it is maintainability, which is how easy it is for you to maintain your backend project. So how is the code base? What is the file structure? Is it easy to understand? Is it easy for the new developers to onboard? So that is what maintainability is. It should be easy to maintain. You don't want to build a backend project that is not maintainable, that is not scalable, that is not extendable, because then you will have problems when you want to scale it. So in order to make our backend project such that it follows SRP and such that it is scalable, it is easily extendable, and it is easily maintainable, we follow this MVC principle. All right, now as I told, MVC stands for models, views, and controllers. Now what are these, each of them? So model is nothing but your database, right? Or you can say it is backend. So backend, you can tell that it is the backend. It is basically the database layer, so where you talk with the database models. Now what are views? So views are basically the front end which interacts with these models. And what are controllers? So controllers, they act as the bridge. So they are the connector, or you can say they are the interface via which your models and views interact with each other. So they act as a bridge. They act as a bridge. So how it typically looks is that you have your models, and then you have your views, and in the between you have your connector, which is nothing but your controllers. So over here you have your controllers, and these two things, which is the models and the views, they interact with each other via these controllers. Alright, so I think that is pretty much clear. So models and views, they talk with each other using these controllers, hence it acts as a bridge. Now what are the cons of this? So the cons of this is that the idea is too much simplified, so that it is hardly followed in the real world. What happens is, when you have all these things in just one particular project, then it becomes a mess. It becomes difficult to scale, it becomes difficult to extend, it becomes difficult to maintain as a code base. So what is the solution? So instead we make some improvements on it, and we will see that what improvements are they. So this is the first con. Now the second con is that views, which is this front end layer, you can say, are nowadays a separate front end project altogether. So this views, they are a separate front end project altogether, which can be, based on React or Next or like anything, right? So as I told, it becomes a mess if you put everything in just one single project. So they are the cons of this MVC architecture. Now what is the improvement? So this is the real world MVC. So in the real world or in industry level, what happens is we optimize this MVC architecture. So this is how it looks. So as you can see, at first, like let's say that here we have the request incoming. So here you have the incoming requests. So what happens is, whenever your requests are coming, like your incoming requests, they come to your routers. So as you can see, you have this request coming from your client. So this can be the browser, this can be your postman, this can be anything which is capable of, of sending requests. So these are the requests coming from your client, and they first hit this routers layer. So you can see that you have all these layers, right? You have your routers layer, you have your validation layer, you have your controllers layer, services, repositories, DB models. Now what happens is, when your incoming request, they come to this router layer. See, what is this router layer first? Let's understand that first. So routers are nothing but your entry point. This request, they come to this routers, they hit this routers layer. Basically what routers does is that it maps your request signature, which is your HTTP method plus your URL, and it maps them to the controller. So let's say that you have a GET request on /API/products. So this GET is the HTTP method, and this /API/products is your URL. So the routers, what it does is that you have your controllers which are defined in your controllers layer, and what routers does is that it registers specific controller for specific for specific request signature. So for this get/API/products, what this router will do, it will register a controller function. So your controller function can look like get all products, and your router will register this controller function for this particular request type. So that is what the single task or the single responsibility of your routers layers is. And here you can also apply root specific middleware. So let's say that you can have your authentication middlewares, you can have your RBAC middlewares. So you can have your auth middlewares, you can have your RBAC middlewares, such that you are protecting your route. So you can protect your routes by creating and using this middlewares also. So that is what the routers layer is. Next, once the request comes to this routers layer, the routers, they call this validation layer. Now what is this validation layer? So let's say that you have an endpoint which is a /post/API/products, which creates a new product. Now inside it, let's say that you have to pass the payload in the form of request.body, and it should look like something like a name, and let's say that name and which is something, and then you have to give a price of it. Now what can happen is this name and this price can be anything. So the client, they can send anything over here, anything. So you need validations, right? You need this validation layer to validate the request body or the request query params or the request path params. You do all the validation inside this validation logic to check if whatever payload is being sent from this request is valid or not. So if it says that there is any invalid data, then it will reject them out. It will not call this controllers. It will just check if there is any invalid data, and then it will give a 400 error, which stands for the bad request error, and it will say that validation failed or something like that. That is completely in our control. So its sole purpose is to validate whatever payload is being sent from your request, which can be in the form of the request body or the request query params or the request path params. So here you can validate if there are any required fields in this payload. So as you can see that you passed name and price, but let's say that you also had to pass another thing, which is the description, right? But you can see that description is not over here, so that is why it is invalid request. So you can check your required fields, then you can check the format of the email being sent, you can check the password length, you can do a lot of validation, and everything will be implemented in this validation layer. Alright, next we have this controllers, which plays a very important role. So see, first your request came to this routers, then it passed through this validation layer. Now inside this controllers, the request, whatever request is coming, it is completely validated. So it is receiving the validated data, and then it extracts the required data out of this request, and then it will call the appropriate service layer. So you see, controllers, they don't have a lot of logic over here. They will just call this services, and then it can return the HTTP response. So its sole purpose is to call this service layer, number one, and number two, it is to return HTTP responses. And yeah, you don't have any business logic over here. Now the service layer. So service layer, it is the most crucial layer. So this is where you include all your business logic. So let's say that you are creating a login endpoint. So over there you have to hash the password, you have to compare the passwords, you have to generate tokens for them. So everything, these are all fall under this business logic, and that is why you have to write everything inside this service layer. And whenever this service layer has to do any DB call, so let's say that you have to make any DB calls. So for that, you talk with your repositories. So this repository is the one and only layer that interacts with your database, and it contains your database queries, and it keeps the services database agnostic. So your service, they don't have to interact with the DB, they will just call this repository functions to interact with the DB. And inside this repository, you can either use an ORM, or you can make raw SQL queries for doing any CRUD operations in the DB. And this repository, it talks with this DB models. So what is this DB models? So database models are nothing but they are models or schema which you define for the database. So it defines the database schema. So if this is the table, if this is the table in your SQL, what you will do is you will create a database model for this, which will be nothing but, let's say, the user model. So this will be the user model, and this repositories, whenever it has to do any changes to this users table, it will dock with your user model, right? Which is actually the database models. So I hope that point is pretty much clear. So your database model, it represents your tables, your entities, the relationships with other tables and everything, right? And it is used only and only by your repository layer. So that is pretty much the MVC that we follow in real world. So I hope this real world MVC is pretty much clear to you, and this is the architecture following which we are going to build our authentication system in Golang. So I hope that's pretty much clear. So that's it for this lecture. In the next lecture, I am going to talk about RBAC and I am going to dive deeper into it. So that's it. Stay caffeinated, keep coding, and I'll see you in the next one.
Let me tell you about that VE. I'ma be your recruit and